Hello friends, I am a cloud solutions architect at Microsoft and I like making LeetCode videos. So today we are going to solve another very popular LeetCode video, which is find first and last position of elements in a sorted array. And if we see some of the popular companies where this question has been asked, there are companies like Facebook, Amazon, Microsoft, Bloomberg, Google, LinkedIn, Apple, Uber, Instacart, Twitter, and TikTok. So that's why I am paying my utmost attention making this video. I hope you also find it informative. So this is a LeetCode medium problem and also very well-liked problem on LeetCode. Basically, we are given an integer array that is sorted in non-decreasing or ascending order, and we are also given a target value. Now, in this sorted array, we need to find out that what is the starting and ending position for this particular target value. If the target value is not present, we need to return -1 as the answer. We are also told one more condition, that this has to be running in big of log n time, which is like a logarithmic time. So definitely this is the big clue that we need to solve this using binary search tree. So over here, I have actually taken these two examples and enlarged them over here. So this is the input array we are given. We can clearly see that all the elements inside the input array are sorted in ascending order. We are also given the target value to be 8. Now in this case, we need to return the first and last position of 8 that is present inside this given input array. And we can clearly see that the first occurrence of 8 is here, where if we see the index value is 3, so that is going to be part of the answer. And the last position of value number 8 is at index number 4, that is also going to be part of the answer. And in this case, we need to return the first and last positions of this target value number 8 that is present inside this given array, which is going to be 3 and 4, and this is going to be the answer we need to return. Same way, if we are, suppose we are given the same input array and this time we are given the target value to be 6. Now 6 is not present inside this entire given array. So because 6 is not present, we are actually going to return -1 as the answer, and this is what we need to return in this case. So basically this is what the problem is asking us to do, and as the name suggests, that find first and last position of elements in a sorted array. So basically that is what we need to find. Now let's see that what are going to be the different approaches to solve this problem. The first approach that comes to our mind is a brute force approach. So in the brute force approach, suppose this is the input we are given and we are told that the target value we are trying to find, okay, let's not put 5, let's put 1. Okay, so suppose we have the target value 1 we need to find. Now in this case, we can clearly see that 1 starts at position number 1 and ends at position number 3, and in this case the answer is going to be 1 3. So because this is a brute force, we are going to apply the most simple logic, and most simple logic is we will start iterating from the beginning until the point where we reach the target value. So over here this is not the target value, so we skip to the next element. Now this is a target value that we are expecting. So because this is the target value, we are going to note its index position as the answer. So okay, this is the first value we find as the answer. Now we will keep on iterating to the next element until either we reach to the end of this array, because it could be possible that all the other values are the target value, or we reach to some value that is not 1. Definitely. So in this case, okay, we reach over here, this is also 1 and this is also 1. The moment we reach to this value, okay, this value is not 1. So because this value is not 1, which means that one value before that has to be the last occurrence of 1. So in this case, okay, index value for this is 4, so 4 minus 1 we will have to do 3. So in this case 3 is going to be the last occurrence of 1, and this is the answer we need to return. Like somehow we keep on iterating and we don't find the target value, so in that case we need to return -1 and the solution would also give us the correct answer. But the problem with this solution is going to be that if we see time complexity, the time complexity is actually going to be big O of n, and we are explicitly told that we need to solve this problem in logarithmic time in big O of log n. So that is not being satisfied in the brute force approach, so we'll have to find a better way. Now the question comes that how we are going to use binary search and how we are going to apply that here. We know using the binary search, it becomes pretty easy for us that we actually have a starting value, we actually have an ending value, we try to find a middle value. Now depending on the middle value, we either remove all the elements on the right side or we remove all the elements on the left side, and we update our starting and ending position, keep on repeating this process until we find the middle value. Now in this case, the logic is not quite simple as just finding the target value. Why? Because it could be possible that there are multiple target values, and what we are trying to find is to try to find the first occurrence and also try to find the last occurrence. If we just apply the simple binary search tree over here, things won't work. Why? Let me quickly show it to you. So suppose in this case, okay, starting position is 0, right? So starting position is 0, ending position is currently 5. So ending position is 5. We set up 2 pointers. Now we try to find the mid value. So mid value in this case is going to be 0 plus 5 divided by 2. So 5 divided by 2, if we take the floor value, we get the value as 2. So 2 is the middle value, which is this in this case, right? Now if you see, for this array, the target we were searching for is 1, and immediately we find the target to be 2, but that doesn't give us any meaningful value because this middle value is already a target, but it is of no use of us because this is neither the starting value neither the ending value. So you must be thinking, okay, there is one simple logic we can apply over here, and that simple logic is that the moment we find the middle value, we start on traversing on one direction, and eventually we would be able to find a place where the value by itself is going to be like the first occurrence. So in this case, what happens? Okay, this is the middle value we found. Now we will start iterating on the left side. So on the left side, we will find, okay, again this value is 1, so still we don't know whether this is the first occurrence or not. So again we are going to take one step on the left hand side, and again this is value 0. So the moment we find a different value than 1, we can clearly determine that the previous value was the first occurrence. So in this case, okay, we can mark this answer as 1. So that is like the first occurrence, and same we are going to repeat the same process from this middle value to the right hand side to find the last occurrence. So if we search right hand side, okay, this is also 1, so we don't know that this is the last occurrence or not. But the next we check, okay, this value is not 1, so definitely this was the last occurrence. So last occurrence in this case is going to be 3. So we mark 3 as the answer as well, and we get the answer, bingo. So this solution would work, and you would argue that, hey, in average case, this works in like big O of log n time, right? But the thing is, we are not concerned with the average case. Why? Because say for an example, you take a scenario where we are given an input array that looks like this, and all the values are actually the target value. So suppose target value we are trying to find is 7, and all the values are 7. So what would happen in this case? Like we would have this starting value, we would have this ending value. Eventually we found a mid value. The mid value in this case is going to be 7. So now we keep on iterating on the left, again on the left, and we reach to the first position, and this is still 7. So we would identify that, hey, this 7 is actually the beginning point. Okay, so 0 has to be part of the answer. Again we keep on repeating on the right side and keep on doing the same process until we reach to the last element, which is still 7, which is still the target value. This is 5. Okay, so this is the answer we need to return. But if you see time complexity, in this case the time complexity would become big O of n. Why? Because we keep on iterating to the next element, and that is not what we want. We want a strict big O of log n time, logarithmic time. So what is the logic we are going to apply over here? So the logic we are going to apply is that definitely we are going to use the binary search, right? That's a given fact, but we will have to make some tweaks. Okay, now I'm going to show you a rough blueprint of the solution we are going to apply. So suppose this is the array we are given. Now what are the things we know? We know that this array is going to be sorted in ascending order, which means everything on the left hand side is guaranteed to be less than everything on the right hand side. I mean less than or equal to. We are also given some target element. So now we are going to first apply the binary search to find target element somewhere. So the logic we are going to use is that, okay, depending on the starting and ending value, we would be able to find some middle value. Now we will try to see that whether this middle value, if that is less than this target value, if that is the case, which means that the target lies somewhere over here. If that is not the case, and if we find, okay, that whether this middle value is actually greater than target value, if that is the case, then the target lies somewhere over here. If both are not cases, which means that the middle value by itself is equal to the target value. So that is great. But the thing is, our job doesn't end over here. We are actually trying to find the first occurrence of this target value and the last occurrence of this target value. So first we are going to be focusing on the finding the first occurrence of the target value. How we are going to do is that, okay, that if suppose for example this middle value, if that is equal to the target value, right? But the thing is we are not sure whether it's the first occurrence or not. We can only define that this is the first occurrence if the value before this is not the target value, or this somehow we keep on doing like binary search, and we find that, okay, the middle value that we were searching for was by itself the first value inside the array, and that was the target value. Either of these two conditions are true, then only we can say that that is the first occurrence. So what we are going to do is, okay, suppose say for simplicity we find, okay, this first value to be target value. Okay, so now we will try to see one value before that. We again find and now because we find this middle value to be target value and we are trying to find the first occurrence, we are guaranteed one thing, that the first occurrence has to be in between these values and not over here. So we can simply ignore these cases and we can update our end value to come over here and then repeat the same process. So now what we are going to do is we are going to bring our end value over here, again try to find the minimum value, the medium value, and depending on the value of the medium value we will be able to find that what is like the first occurrence. Same logic applying, we would be able to find the last value, and for the last value logic we are going to use is that if the middle value is equal to target value, then if that is at the position where the next value of that, if that is not the target value, then we can say that this was the last occurrence of the target value and we put it in the answer, or we somehow find the target value to be the last element by itself. In either of these two cases this goes in the answer as the last occurrence. So let's try to understand this with an example, and then it would make more things more clear. So again we are continuing with the same example we are given. Now let's mark starting and ending value. Currently the starting value is equal to 0, the ending value in this case is 5. So if we try to find the middle value, the middle value is going to be 5 divided by 2. We are going to take the floor value, so which is going to be 2. So this is currently the middle pointer we have. Now if we compare the middle point, lucky in this case middle point by itself is the target value. So now because this is the target value, we are trying to find the first occurrence. So because we are trying to find the first occurrence, we will try to see one value before this target value. So one value before this target value is also 1, which means that amongst these places there exists the first occurrence of this target value 1. So because of that, now we are going to update our end pointer. So now our end pointer position becomes midpoint whatever we find -1. So now this becomes the new end pointer. Okay, so currently the end pointer position is 1. So if we do like 0 plus 1 divided by 2, we got 0.5. So basically mid pointer is going to be 0 because we are taking the floor value. So now this is the mid pointer. If we compare this mid pointer with the target value, this mid pointer is actually less than target value. So because this is less than target value, we will have to update our start pointer. So now start pointer, we are actually going to update one position to the right, and we are going to keep on repeating the loop until the point where we find like either the start value crosses end or either end value crosses start. So currently both are at the same position, that is acceptable. So currently the starting pointer is also 1, ending pointer is also 1. In this case middle pointer is going to be 1 definitely, and because this is going to be 1, okay, this value is actually the target value. Now we compare this with its previous value. The previous value is not target value. So because this previous value is not target value, we can say one thing for sure, and that is that this is the first occurrence of this target value. So first occurrence of the target value, we are going to mark the index number. So index in this case is going to be 1, and that we are going to store. Okay, now we are done half the work. Now we are trying to find the last occurrence. Now for the last occurrence, again we are going to repeat the same logic and we are going to do everything from the beginning. So let me clean this up a bit. Now we are trying to find the last occurrence. Now for the last occurrence, okay, we find the middle value is equal to target value. We compare the next element to the middle value. This is also target value, which means that the last occurrence exists somewhere over here. So which means we will have to update our starting pointer. So when we update our starting pointer, we get the new values as, and also we can ignore all of these cases. So now, okay, this is our values. So in this case, if we try to find, okay, we find the middle value to be 3 is actually greater than our target value. So because of that, we will again have to shift our end pointer on the left hand side. So if we shift our end pointer on the left hand side, our end pointer is going to end up over here. So currently starting and ending value both are located at position number 3. So obviously middle value is also going to be located at position number 3. So now this is the middle pointer. Okay, this is exactly the target value. So that solves one part of the problem. And now we will try to compare its very next element, and that value is not the target value, which means that this is the last occurrence of 1. So the value is 3, so 3 we are going to mark as the answer. So now we find, okay, f is equal to 1 and l is equal to 3. So we find both the values, and that is what we need to return as the answer. And this is the whole logic we are going to apply over here. If you see the time and space complexity, in this case the time complexity is actually going to be big O of log n, and it's pretty self-explanatory that in every single equation we are eliminating half of the values on one side to find the correct occurrence position. So this is a very good example of using binary search to solve the problem in a little bit different manner. Like the thing is, definitely underlying concept is a binary search, and everyone knows that, but still this is doing things a little bit differently. And I would be jumping to the code now. Okay, so before we actually start implementing the search range method, first we'll have to define that we actually need to find like the first and last position of any given element, right? So we are actually going to create a helper method for that. And for this particular helper method, I have named it as find bound. And this helper method is actually going to return the integer value of whatever the bound we need to find. Like now the thing is, over here we need to find the first and last positions. So rather than having two separate methods, we are only going to have one method where as an input we are taking the nums array, we are also taking in the target, and we are also taking in a boolean character that is first. So this character would define that whether we are trying to search like the first occurrence of any particular target element or the last occurrence. So that's settled now. Now we are going to create some helper variables. So first we are going to create two pointers, start and end, and we are going to assign their values as 0. And we are also going to create while loop, that while start is actually less than or equal to end. Now inside the loop, first of all, we are going to calculate the mid pointer. Now with this method, there could be two possibilities. It could be possible that we are trying to find like the first occurrence. So which means in that case, the value for this is first would be true. So first we will calculate for that scenario, and then we will make the calculations for the second scenario. So what could be the condition that we actually find the correct value? And the condition is that if the mid value, if that is equal to the starting value, so if that is the case, or we found out that the nums of mid minus 1 is not equal to target. If that is the case, we can also define this to be true and simply return the mid pointer as the first occurrence of the value. If that is not the case, basically we will have to shift our search. So every single time we are going to update our end pointer to go one position left of mid, so mid minus 1. Now that takes care of the scenario where we are trying to find the first element, right? Now for the last element, we will also have to do some calculations. So in order to find the last value, basically the condition is that if either the middle value is equal to the end character or end pointer, or the nums of mid plus 1 is not equal to target. Either of these conditions are true, we can simply return the mid. If that is not the case, this else condition is trying to find for the last case. So in that scenario, we are actually going to update the value of our start pointer. Now we have taken care of most of the things. Now we need to also make changes depending on the position of mid value. So if that is not equal to target, so if that is the case, basically we are again going to make some changes. So first we are going to have the condition that else if the nums of mid, if that is greater than target, which means that we need to update the end pointer. If that is not the case, we are simply going to update the start pointer. And somehow we get out of the loop and we don't have the answer yet, we can simply return -1. Now from our main method, we are actually going to call the helper method that we have created, and we need to find like the first and last bound. So first we are going to create the first element, and we are, for that we are going to call this find bound method. We are also going to keep a condition that if say for example we get the answer as -1, we can simply return -1 as the answer. And if somehow we do not get -1 in the return, which means that first element exists, so last element also has to exist. So we are also going to create another parameter called last to find the last occurrence, and again we are going to call the same method, but this time we are going to keep this parameter as false, and that way it would be able to calculate the last value. And simply we need to return the new array and add these two entries of the first and last. I think that should have taken care of all the scenarios. Let's try to run this code. So over here, I actually forgot to enter one critical condition, that if the given mid value, if that is equal to the target value. So if nums of mid that is target, then only we need to proceed over here. Okay, now it makes sense. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And seems like our solution is working as expected. Our runtime is actually beats 100% because it's the runtime is 0 millisecond. And even in terms of space complexity, our calculation is pretty efficient. I think LeetCode changed their UI, so that's why we are seeing it differently. And I would be posting this solution in the comments, so you can check it out from there. Thank you.